Hi, boys and girls. Today's lesson is section 2.5, solving equations involving absolute value. All right. Absolute value, these are these little goalpost signs. They look like little goalpost signs here. You see how they are? And in the past, you've known them as the symbols that make negative numbers positive. They don't do anything to positive numbers. The reason for this is that absolute value deals more with how far from a certain point is this place. How far from 0 is -4? Well, distance is always positive. So when we're asking how far from 0 is -4, you don't say -4, you say 4, okay? And that's what the idea behind absolute value is. This is a lot of words. Basically what it says is if you have an absolute value equation, let me get my writing thing fired up here. If you have an absolute value equation, you're going to have some gobbledygook inside this absolute value sign, and it's going to be equal to, oh, say 7. All right? What you don't know is, did the gobbledygook equal 7, or did it equal -7? That's the thing you don't know. So when we're solving absolute value equations, we have to take that gobbledygook and say, okay, maybe it was 7, but then we have to take it and say, well, maybe it was -7. So we're generally going to have two solutions to these equations, the positive solution and the negative solution. Okay. Moving on. Well, that's what all those words say. Okay, so they're saying consider the equation x equals 3, the absolute value of x equals 3. This means that x is one of two things. X is either 3 or x was -3. We don't know, so we mark both on the number line. When we graph the solution, we put a dot at -3 and a dot at 3. You do not put a dot at 0. I don't know why they have a dot at 0. There's no dot at 0. You only graph 3 and -3. Now, this down here, I've got a star by this. They're saying that when we're solving these absolute value equations, you must first isolate the absolute value on one side of the equation. And I'm going to show you the beginning problems, it already is done for you. It's only the problems toward the end, where the more advanced ones, where you would have to actually manipulate that, and I will show you how to do that. I love absolute value equations, they're my favorite. Okay, well, I know I said multi-step equations were my favorite, but those two. I kind of like equations. All right, so here we're solving an absolute value equation when n is greater than 0. That's pretty funny too, because what they're saying is that absolute value can never be less than 0. Absolute value will never spit out a negative number, therefore it can never be less than 0. So that's what this n greater than 0 thing means, okay? So we have this absolute value y plus 2, and we know it's equal to 4. What we don't know is, was y plus 2 really equal to 4? Or was it equal to -4 and the absolute value symbols changed it to positive? That's what we have to find out. So we have to solve two equations. We have to solve for the possibility that y plus 2 was just 4. But we also have to consider the possibility that when we added y and 2 together, we actually got -4, and the absolute value signs made it positive. So we're always going to break it up into two possibilities, the positive possibility and the negative possibility. Then they went through and solved for y. All right, over here, y is equal to 4 minus 2, which means y is 2. All right, and over here we have -4 minus 2, which is -6. So, oh, I guess they already wrote the 2. It was the 6 they didn't have. I hate Reveal. I did not pick this program. We'll put -6 is the other one. They already had the 2 for me. So we graph -6 and 2 on the number line by making a dot at -6 and a dot at 2. Okay. Super fun, right? No, you're going to love this. Now, we can substitute -6 and 2 into the original equation to see if we're right. This is, substitute and check. So we took the 2 and we put it, we took the -6 and put it in this one. -6 plus 2 is -4. The absolute value signs made it positive, so that worked. Over here, we substituted 2 for y. 2 plus 2 is 4. +4 is +4, and that one worked. Okay. Now we can do it on our own without all that gobbledygook they put on the page. Okay, so here's the problem they've given us. 2t minus 4, the absolute value of 2t minus 4 is 8. There's two possibilities, though. There's a possibility that when we solved 2t minus 4, we got 8. That's this one. But there's also the possibility that 2t minus 4 was really equal to negative 8, and the absolute value signs just changed it. All right, so we have to get two solutions here, the positive and the negative solution. Here, we're going to add 4 to both sides to isolate our variable term, which gives us 2t equals 12. And then we divide each side by 2, and we get the t might have been 6. The other solution is where the answer was negative. So if we add 4 to both sides on this one, we get 2t equals negative 4. And when we divide both sides by 2, we get t is negative 2. Interesting, this had the same solution as the last one, didn't it? Wasn't it 6 and negative 2? I think it was 6 and negative 2. Or maybe it was negative 6 and positive 2. I don't know, I forget. We mark 6 and negative 2 on the number line, and that's how you graph your solution. Okay? Now, you want to write the solution set. The solution set is negative 2, 6. I always start with the smaller number. All right, now here we have a problem. See, we've got some stuff in an absolute value sign, and it claims it's equal to negative 1. But I just told you that absolute value signs make everything positive. So this is broken, okay? Negative 1 means that the distance between 3x and 4 is negative 1. Since distance cannot be negative, the solution is, and I believe they write the null set here. There's no solution. It's just no solution set is a circle with the line through it. No solution. Okay, you can't have it turn out that way. So be on the lookout because they put some zingers in there where they put it equal to a negative number, and you got to remember it can't happen. All right, now they're asking it kind of backwardsy. See, and here's that circle with the line through it I was telling you about. Yeah. What statement must be true for the solution of ax plus b equals c to be the null set? Well, just like the last example, the only way to get the null set answer is for c to be less than 0. Okay? So, or if c is negative, which is less than 0, the solution will be the null set. So the correct answer to this one was C. I hope you're having as much fun as I am. Oh golly, look, it's a word problem. Just love those two. Depending on the size of each song, Luna's phone holds an average of 2,000 songs, give or take 250 songs. Write and solve an equation involving absolute value to find the maximum and minimum number of songs that Luna's phone can hold. All right, I thought this was a little overwhelming at first when I first started teaching algebra years ago. And so I added this little thing down here. This isn't in your workbook, but the standard form of an absolute value equation, it would be x minus whatever the midpoint is, and then the number over here is the distance between the endpoint and the midpoint, okay? So for this example, the midpoint is 2,000 songs, and then she has the capability of maybe 250 extra songs, or it could be 250 fewer songs. Okay, but the midpoint is the 2,000. So they've set the equation up with x minus the midpoint equals positive 250, or x minus the midpoint equals negative 250. So what does this look like over here? You got to fill this out. The difference between the number of songs and 2,000 is 250. If x equals the number of songs, then it looks like this. It looks like x minus 2,000 equals 250. That's your equation. Okay? So then they come over here and they say, well, x minus 2,000 might be positive 250, or x minus 2,000 might be negative 250. They solve by adding 2,000 to both sides, and then they simplify. So the solution set is 1750 and 2250, really hard to write in that small space. And that's how you solve that one. Okay, so you might want to jot this down. I've got it on the next couple of screens. The standard form is the absolute value signs with x minus the midpoint equals the distance between the endpoint and the midpoint. Be careful, if your midpoint is negative, this will be x plus the midpoint because it's minus a negative and it makes it a positive. Right. Okay. Skydiving, something I will never do, ever. No, 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 no. I'm not a skydiver. I'm afraid of heights. I can't even climb a ladder. Okay, so for this one, it takes approximately 6 minutes for a skydiver to land after she jumps out of a plane. Can you imagine free falling for 6 minutes? Oh, no, 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 no. Give or take 30 seconds. What is the range of time in seconds it could take the skydiver to land? So first of all, I noticed that it starts off telling me 6 minutes, give or take 30 seconds, and it wants the range of time in seconds. So the first thing I had to do was change 6 minutes to seconds. And now 6 minutes is my midpoint. It's 6 minutes, could be 30 seconds longer, could be 30 seconds less. 6 minutes was my midpoint. So that's why my equations are set up x minus 360 equals 30. Okay, that's my equation. But now I have to come over here and solve for the positive possibility and the negative possibility. The only thing that is different here, this 30 was positive, this 30 is negative. Okay, so we're going to add 360 to both sides. And we get x is equal to 390. All right, and here we're going to add 360 to both sides. And we get x equals 330. So that means that you might land as quickly as 330 seconds, or it could take as long as 390 seconds. Those are your two solutions. I know they jump into word problems here pretty quickly, but many of the examples I will be doing during our Zoom class, I will do, not word problems. They'll just be straightforward equations. Now, the next thing they're going to ask you to do is to write your own absolute value equation, and they're going to give you the graph of the solution, okay? What you do, you remember the standard form here, okay? The standard form is going to really help you here. Standard form of an equation, x minus the midpoint equals the distance between the endpoint and the midpoint. If you have these two dots as your solution, okay, what you do is you've got to find the midpoint of those two. The best way to do it is to find the average of the two numbers. Add them together and divide by 2, okay? If you add them together, they equal 44. Divided by 2 is 22, which means 22 is your midpoint, okay? So you will have x minus 22. Write that, oh, not on pen. X minus 22. And what's the variation? Well, how far is the midpoint to each of the points? 5. So x minus 22 equals 5. This is the equation that created this solution set. Now you see why I love these so much. Okay, so here they've given us several, and we need to match them up, okay? Well, remember that it's always x minus the midpoint. So look at these and ask yourself what the midpoint would be. Remember my little trick. A negative 2 and a positive 4 gives you 2. 2 divided by 2 is 1. The midpoint's going to be 1 on this one. So 1 is the midpoint. And what's the distance? 1, 2, 3. So we're looking for one that has a 3 here and a positive 1 here. All right. But remember, it's x minus the midpoint. So that's why it looks like a negative 1, because the formula is x minus the midpoint. The midpoint's 1. Okay, so this one is x minus 1 equals 3. Now we look at the next one. Add negative 2 to 6, you get, or said the answer, didn't I? Negative 2 to 8, you get 6. 6 divided by 2 is 3. 3 is the midpoint on this one. So we're looking for an equation that has 3 here. But you'll notice this one has plus 3 and this one has minus 3. Here's the difference. This 3 was a positive 3, because remember the formula is x minus the midpoint. How did this one get to be positive? I'll tell you, because this 3 was negative, and it was x minus negative 3, which made it x plus 3. So this one has a midpoint of -3, and this one has a midpoint of +3. Which is this? This is +3. So I can tell you right off, this one's got to be our winner chicken dinner. All right, x minus 3 equals 5. And is it 5 moves between the midpoint and the ends? 1, 2, 3, 4, 5. You bet it is. No, we got that one right. All right, here we have -5. This is -5, and this is 7. 7 plus -5 is 2. 2 divided by 1, or 2 divided by 2 is 1. There I go again, telling the answer, which is 1. All right, so I'm looking for a midpoint of 1. I'm looking for x minus 1. I see 2 of those. Now, forget that I've already used this one, so it's got to be this one. My next step would be to say, okay, well, how many spaces is it from the midpoint to this dude here? 1, 2, 3, 4, 5, 6. So this number has to be 6, and this number has to be 1. So my equation for this one is x minus 1 equals 6. And by process of elimination, I think we all know what the last one is, but I'm going to drive this into the ground. All right, this is a -9 here, and this is a 3. -9 plus 3 is -6. And -6 divided by 2 is -3, which gives us our midpoint. Now, this is the weirdie. Because the midpoint was -3 and the standard form is x minus the midpoint, we would have x minus -3, which is rewritten as x plus 3. Equals 6. Is it 6 spaces from here to here? 1, 2, 3, 4, 5, 6. You bet it is. Good times. All right, and that brings us to our practice problems, okay? And we do those in class. So I hope you had a great time watching this video. I hope you took lots of notes, and I look forward to going over this with you in class and doing the practice problems. Until then, catch you later.